destruction of materials by chemical reaction within environment. It's a photochemical oxidation of metal. So it's an electrochemical oxidation of metals in presence of oxygen. Let me write once again. It is nothing but gradual destruction of material by chemical reaction, and this chemical reaction happens in environment on its own. This doesn't happen in the labs. This happen in, they do happen in lab also, but they happen in environment. Right? It's electrochemical oxidation of metal. Right? Electrochemical oxidation of metal. Rusting of iron, if you see, is one good example of corrosion. Right? So this corrosion, it slowly coats the surface of the metallic object with oxides. For example, iron, it slowly coats with oxide. This is Fe2O3, whatever you see, right? Rusting of iron, tarnishing of silver. In the copper object, you see the green coating comes. They are all examples of corrosion, and there are huge damage to the economy. The buildings, the bridge, the ships, they all got damaged because of this. Huge money is wasted every year because of this, and huge life is also in risk because the bridge is weak. People may die. The bridge may collapse. Right? So if you see, in corrosion, generally the metal oxide is formed by the loss of electron to oxygen. You see, metal oxide formed by loss of electron to oxygen, and they form oxide. Right? For example, corrosion of iron. I'll take the example of corrosion of iron. It happens in the presence of water and oxygen. I remember we have done an experiment where we have kept, we have taken 3 test tubes. In one test tube we have kept only water and iron, and we have sealed that with some oil. So that had only water. In one test tube we just kept only oxygen, and one test tube we kept oxygen and water with nails, and we saw that only the one which had both oxygen and water got corroded. The other were not corroded. So that means oxygen and water both are required for corrosion. If you see the oxidation reaction, right? This is the iron. This is the iron. This is my iron. Fe. Right? Fe will become Fe2 plus in the aqueous mode. So the oxidation happens. Right? And this Fe2 plus, actually, if you see, they will react further to become, with oxygen, Fe2 plus, it forms Fe2O3. And that is my rust. See, Fe, iron, will lose electron to form Fe2 plus. So that is the oxidation reaction. Correct? If you talk about reduction reaction, the oxygen will react with H plus and form water. See, this is the water. Water will have this H plus and OH minus. So we have these electrons here. This electron, correct, and this H plus, correct, and this oxygen from air. It's air here, oxygen. So these 3 things will combine, and the reaction will be oxygen plus 4H plus 4 electron, 2 electron, one more oxidation will happen, will give 2 more electron, it will form 2H2. And for this, if you see, the E is 1.23 volt. That means it is a spontaneous reaction. Right? Spontaneous reaction. If we talk about the oxidation reaction, Fe gives Fe2 plus 4 electron. Sorry, 2 electrons actually. 2 electrons. Yeah. For this, the E is minus 0.44, and this is the E reduction. But it is the oxidation reactions. If we talk about the E oxidation, that will become plus 0.44. That means that is also a spontaneous reaction. So both are spontaneous reaction. Reaction 1, reaction 2, both are spontaneous reaction that can happen on their own in the nature. Correct? So this is oxidation at anode, we can say, and this is at cathode, we can say reduction reaction. Correct? So if you add these 2 reactions, you'll see that you are getting Fe2O3, right? This is my Fe2O3. Again, this also reacts with oxygen to get Fe2O3. Once you get Fe2 plus, you can easily get Fe2O3 when it reacts with oxygen. Correct? So the ferrous ions, whatever you have seen, right, is further oxidized to become ferric ions, and that is called rust. This is called rust. Correct? So if you see this two reaction, if you want to find the overall reaction, let me write here. If you join the reaction, what you get is iron, this part, when it reacts with oxygen here, O2, and then 4H plus, electron cancel both sides, it gives Fe2 plus and water. Correct? So that is the reaction we have. So we want, yeah, correct, that's the reaction we have. Now this Fe2 plus will be further oxidized, become to ferric, and that is rust. Correct? Let's see how can we prevent the corrosion. We can prevent the corrosion because corrosion is required to be prevented. You can save a lot of money by preventing corrosion. You can save life also by preventing corrosion. It is something which is not desirable. The first way is you can just coat the metallic surface with paint. Right? First is you do a paint coating. But that is costly. If you have a big ship, paint, it costs, right? Second thing is, instead of coating with paint, you can coat with metallic surface. Coat with metallic surface for the metals which are not reactive. For example, zinc, aluminium, right? You can coat with this other metals which are inert to corrosion, and this you can do using electroplating. We have seen that. The third is the electrochemical method, that is called sacrificial electrode, and this is an example of sacrificial method. Right, this is the electrochemical method, right, using the electrochemical method. So if you see here what we do, the ships, we apply small rod of magnesium or zinc, right? Magnesium or zinc we apply here in this iron. If you assume that the whole ship is of iron, we apply this, and with that I'll show you the magic, what happens. So in this, what will happen, these magnesium or zinc which we applied, they will corrode itself, they itself will corrode, but they will save iron to corrode, right? Because they are more reactive metal, so they will act as anode and they will be oxidized. For example, in this case what will happen, magnesium will become Mg2 plus, it will take the 2 electron. So if you see here, the reduction is minus 2.34, but this is oxidation reaction, so oxidation E will be 2.34 volt, that is, it is a spontaneous reaction. Correct? Iron being less reactive, they'll act as cathode, and in iron, instead of iron getting oxidized, because that will, iron will act as my cathode and this will act as anode. Correct? So at anode what will happen is, this is my anode, this is that cathode. My oxygen will react with water, will take 4 electrons and form 4 OH minus. So with this, the iron will be prevented from rusting. But again, see, this is the example. This is an example of a zinc that was placed in ship. This is the same thing which you are seeing here. This is the same thing, the real one actually. And if you see, this zinc has got corroded, correct? But has saved iron, and that is how it works. But again, this get corroded and then you have to replace this from time to time, but that saves money, right? Because you are saving from the whole ship to get corroded. This is a very good method that is used, sacrificial method. The last topic for this chapter we'll understand is hydrogen economy. So this is to save our earth. See, currently we use more fossil fuels to produce electricity, to run our cars. Everywhere we use petrols, coal, a lot of fossil fuel is used, right? And these fossil fuels, carbon dioxide is produced, that is the output. All these fossil fuels which we use, like coal, petrol, right? This gives carbon dioxide as output, and this carbon dioxide leads to pollution, right? It also leads to greenhouse effect, right? And with this, the earth temperature is increasing. With this, the earth temperature is increasing, and with this, what is happening? The ice is melting, and there is ice melting. The low-lying areas, the coastal areas, low-lying areas or low-lying coastal area are getting flooded. Correct. Here, hydrogen fuel cell which we have seen, it provides a better alternative, because here the output is only water, which you can actually use it. In fact, the fuel cell which I just discussed, there the output is water, that was used for a Russian spacecraft mission Apollo, and the water output which it was, the output of water was being used by the astronauts for drinking. Correct. So, and also here, if this, right, this can be a renewable non-polluting source of energy, this fuel cell. And the vision to use more of hydrogen gas fuel cells to produce electricity and less of fossil fuel, to have a non-polluting earth, that vision is called hydrogen.